Okay, so I will present our work on building the end-to-end SLU baseline models from our team, and also present the experiment result on the two data sets. So let me recap our idea for building the end-to-end SLU system. That is, instead of using the traditional ASR and NLU pipeline, we're trying to explore a end-to-end system that can predict the SLU output directly from the acoustic features. So what are the output, or what are the possible output in the end-to-end system? There are three. The first is the to extract the user intent from the utterances, and there are two possible ways to representing it. The first is the N-way classification, that is to combine all the intent tokens into one label, like the second line in the table here is the increased lightning spectrum. Also, the second way of doing it is to predict three tokens sequentially. And followed by the intent, the other task is to do the slot filling. And the traditional way of doing it is to use this BIO formatting of it. B represent begin of a slot value, O and I represent inside and outside. So by aligning this BIO tag with corresponding words, we were able to extract the slot value from the utterances. So these are the three outputs we have used in our experiment. So these are the four baseline structures we have explored in our experiment, replicating the structures used in one Google Teams paper. The first one is a direct model, which is simply encoder-decoder structure outputting the SLU tokens from the audio signals. And by SLU tokens, it can refer to either intent tokens or slot tokens. The second one is a joint model. It predicts the transcript tokens concatenated followed by the SLU tokens. And so by using that model, we're expecting to provide more context information to the input or to the output. And the third one is the multi-task model. So it uses a shared encoder for predicting the transcript and the SLU tokens. And the first model is the multi-stage one. We're expecting to backpropagate the first ASR stage by the SLU targets. So we're expecting the joint model and multi-task model to perform better than the other models. So the dataset we have used for the experiment is the Fluent speech command dataset. It contains about 30,000 utterances. That is one example here. The audio inputs is light on to control the home devices, and the slot label we're trying to fill is the action, object, and location. It's actually a relatively small data set compared with the large data set we have used for pure ASR or NLU. So that may give us some variation in the experiment results. So this is the experiment result we have got. And so apart from comparing all the four baseline models, we are also trying to find to compare between the RNN-based encoder-decoder with the transformer-based version. And if we compare this result vertically, we can see that either for RNN or transformer, the multi-task model actually gave us the best results among all the baseline models. And if we compare the results between the multi-stage model and the direct model, we can see that even though the accuracy score is similar, but the multi-stage model is still slightly affected by the ASR system error. And if we compare this table horizontally, we can see that generally the LLM-based model are performing better than the transformer-based model. That's probably because the transformer structure is slightly is a bit complicated for this small data set, which only have about 100 vocabulary sets. So, so probably for this data set, the multitask model with the RNN-based encoder decoder structure is the best fit. Yeah, that's has been covered. And the second data set we have used is French data sets. That part is primarily done by our group member Sahar. She's not able to join, so I'll have her to present the result here. The media dataset is a French dataset for querying hotel information and reservation. And the main difference between this media dataset from the Fluent speech dataset is that it have a much larger vocabulary dataset of vocabulary size, and also it uses a different slots formatting with the example here. It encloses the word corresponding to the slot value into these two brackets for representing the slots. So these are the 4 tasks we have performed on the media dataset. The first is the ASR task with pure media dataset. The second one is the ASR with data augmented with the port media data. And for SLU, we perform 2 tasks. The first one is the SLU predictions with these BIO formatting, which predicts only the BI labels, like the second line here, a second line in the table. And the fourth task we have performed is the joint ASR and SLU learning, which predicts words along with the SLU text. Like the third line here, we have ignored the old label, which doesn't is not required for slot filling. So that's the result for the ASR and the SLU system on the media data. So for the ASR, we can see that by augmenting the system with port media data, we can see there is over 1 point word error rate improvement. And for the SLU tasks, I would say that we probably need to do more experiments on the SLU predictions because we are actually using same structures for all 4 tasks, which probably not a good fit for the SLU predictions. But we can see that for the joint ASR and SLU learning, the transformer-based structure can have about 22 concept error rate. If we compare that result with the state-of-the-art result on the media data, it actually have 2 points concept error rate improvement, which is, I would say, is a improvement. And but for the other parts, like for the SLU predictions, we probably need to do more improvements, like tuning the parameter or changing the model structure. So regarding the future work in that part, I would say we will put more emphasis on the ASR SLU joint learning, because for the slot predictions, it's more meaningful if we can get both the transcript tokens and the slot label tokens as output. So probably in the future, we will put more emphasis on the joint learning fields. And that's concludes my part. I can take any questions if you have any problem regarding the baseline or the experiment results. Oh, I'm sorry. I'm
No
maxing
problem.
that.
Don't worry about it. Keep going.
Right. Questions from the audience? Any hands?
So if our next speaker is ready to go and has a microphone on, then we're ready to go.
Hi, can you all hear me?
Yep.
Okay, so I'll just request remote control then. Okay,